Welcome back to trapezoids. In the last video we talked about exactly what a trapezoid is and what its pieces are called. We have bases that are non-congruent, legs that are congruent, or that can be congruent, don't have to be. We talked about that the angles on the same side are always supplementary, meaning they add to 180, and then we discussed the mid-segment, that it is parallel to both bases and it's the average of the bases. We saw how to find a mid-segment if you know both bases, and we saw how to find a base if you know the mid-segment and the other base, and then we even talked about how to check those answers. Now we're going to look at an isosceles trapezoid. An isosceles trapezoid is one in which the legs are congruent. So just like on an isosceles triangle, you're going to have two equal legs. Okay, so two equal legs, here and here, here and here. Okay, all right, so we have two properties that are super important to know about our isosceles trapezoid. The first one is that both pairs of base angles are congruent. Both pairs of base angles are congruent. So when I look at this base, this angle is exactly the same size as this angle. When I look at my other base, this angle is exactly the same size as this angle. Okay, it still has all the other properties that we discussed. So these two angles together are still going to add up to 180. These two angles together are still going to add up to 180. The only thing that's different is these two now have to be the same as each other, and these two up here have to be the same as each other. Whereas before, these two angles don't have to be the same. The two on the base don't have to be the same. If my legs are different, they will be different. When my legs are the same, they will be the same. My second property that I need to know about my isosceles trapezoid is that my diagonals are also congruent. So here and here. Okay, they are the same. Now it's kind of hard to mark on there because it has an intersection. So if I'm gonna go ahead and label this as A, B, C, and D. So that means AC, the distance from A to C, that diagonal, is exactly the same as the distance from B to D. Okay, and that is one of the big reasons why you can't use congruent diagonals to say, oh, the diagonals are congruent, this must be a rectangle. Because it's true for rectangles, but it's also true for your isosceles trapezoid. Okay, so you need to have a little more information if you're trying to classify a figure than just congruent diagonals. Another thing about the diagonals on this number 2 is that the intersection divides proportionally. And it's not like a centroid where it's like 2/3 or anything like that, but what it does kind of do that's kind of neat is this intersection is going to make these two pieces a little isosceles triangle under here, and these two pieces are going to be the same, so you'll have a little isosceles triangle up on top as well. This intersection here can have any kind of different angles, so that don't think we have perpendicular or anything going on. There's no perpendicular happening with the trapezoid, okay, unless there's just happens to, it might accidentally fall in there somewhere, okay? But we do end up with little isosceles triangles at the bases, which means they will also have congruent little base angles inside there. Kind of cool. All right, let's find each angle. When I look at this picture, I can see that I have, I'm trying to find a color I haven't used. Okay, I have angle K is 50. Since I have tick marks on my legs, this is isosceles, which means my base angles are congruent. So if I look at where my parallel sides are, those are my bases. So if this is 50, this is also 50. And then I need to figure out what these two are. There's two ways to do that. I could say, well, it's a quadrilateral, so the four angles have to add up to 360. I've already used 100 degrees here, so there's 260 left. which means these each have to be 130. The other way I could do it is I could say, well, in every trapezoid, the angles on the same leg are supplementary. So if this is 50, I need 130 more to make my 180. Okay, that's probably a little less steps to do, is just to subtract the one angle you know from 180 to find the other one. Okay, now keep in mind your trapezoids are not always sitting nice and upright and pretty with your bases being on the bottom and being on the top. If I look here, this has been kind of rotated. This K to J is a base, and this L to M is a base. So that means these two angles are both the same. They're both 118. And these two angles are both the same. I just need to figure out what they are. Again, you could use your 360, subtract your 118s from 360, 118 and 118, and then divide what's left in 2. Or I could just say, well, I know the two angles on one leg have to be supplementary, so I could just do 180 minus 118 and get that this angle has to be 62, which means the other angle on the same base also has to be 62. Okay, let's do a couple more isosceles triangles problems. Working with some angles and some segments. All right, so on this one we're going to find x. Remember what I said was one of the kind of neat things about the intersection? If this is, it doesn't tell me it is, so if parallel, or if isosceles, because I don't see that it is, so I'm going to add in tick marks and say if I have tick marks here, if my two legs are the same, and I'm actually going to make all of these isosceles. This one's already marked isosceles for me. Okay, if these are isosceles, then when my diagonals intersect, they make little isosceles triangles at the bases, one here and one here. Okay, the angles on the side are not isosceles, okay, because they're going to be different side lengths. But these two, these at the bottom and at the top, will be by the parallel sides, which means these base angles, guess what? They are exactly the same. If one is 28, then the other is 28. Easy peasy. Okay? All right, so now let's look at this middle one. If this is also an isosceles triangle, or trapezoid, I keep saying triangle, then I know if this is 40, then the other angle on the base over here is also going to be 40. And this here is going to be 15. Okay? Now, I could figure out what that whole angle up there at the top is, because I know that 40 and 15, this is 55, and I could do 180 minus 55. I can't reach. 180 minus 55. That angle up here is 125. But I don't know how that 125 is divided into these two pieces, because they don't have to be the same. So I need to figure out how big each one individually is. So what I'm going to do, actually, is use my idea of triangles. And I'm going to look at just this triangle that I'm coloring in yellow. Because I know how many degrees are in a triangle. Every triangle is 180 degrees. So if I take that triangle and I say this angle here is 40, this angle up here at the top is the one I'm trying to find, then this angle over here, it's not 40, it's not 15, it's this whole angle, which is 55. Angle addition postulate says that angle is 55. So to find out what's left for this angle up here for x, I'm going to do 40 plus 55. That's 95. Take that away from the 180 that's in the whole triangle, and that's going to leave me with 85 degrees. For this angle x. Okay, so kind of neat. We're still using all those triangle properties. That's why it was so important to make sure we understood them, and that's why we spent from literally October to just this past week working with triangles, okay? Because triangles are the foundation of pretty much everything we work on. All right, let's look at this last one in this section. It says K to B is 21.9, so K to B, that's this little piece here, is 21.9. That means that this piece here is also 21.9. Okay, all right, so now the next piece says FM, F to M is 32.7. F to M, this whole piece here, is 32.7. Sorry, I moved my paper. Find FB. How far is it from F to B? How long is that piece right there? Okay, well, segment addition says if I take F to B and I add that to B to M, that's going to give me this whole segment, 32.7. So to find out how long FB is, I just need to subtract the 21.9. So the distance from F to B, just that little short piece there, is equal to the whole thing, 32.7, minus the piece that we already know, the 21.9, will leave me with what's left for the blue, 10.8. And I don't have any units here, so I'm just going to say units. 10.8 units. Okay? In the next video, we will come back and look at area of a trapezoid. All right? Thank you so much for watching.